So as usual with word problems, the idea behind them really is to translate what you've been given into an algebraic expression or an equation and then solve the equation. That's the idea. So this is question 1, and these are examples of just sort of fractional arithmetic, really. So if 2/3 of a number is added to 1/2 that number, the result is 35. What's the number? So the first thing you need to do is set a variable to the unknown. I tend to use x as often as I can because it's just convenient, really. But you could call it n for the number or something like that. But I'm just going to use x. So I construct my equation first, 2/3 of a number. Now watch how I do it. I know that's 2/3 and so do you. That's what 2/3 looks like. But what I do is I write, well, let me just explain, because I'm going to be doing it over and over again over this session. So 2/3 of x is how I would write that, right? But really, that means 2/3 of x over 1, which is 2x over 3. So what I tend to do is when I've got a fraction of a variable, I tend to write numerator x over denominator. Okay? And I'll do that directly. You don't have to, but I think it's not a bad habit to get into. So I'll just put a solution here so it's separate. So 2/3 of a number, so 2x over 3, is added to 1/2 of the number, so I'm adding 1/2, so I'll just make that x on 2. 1x on 2, right? And the result is 35. What is the number? So there's the modelling of it. Now, if I was being a bit more articulate with my solution solving, I would say let x be that number. Okay, so I'm being a bit rough with my working out here. Now that I've got my equation, it's a matter of solving it. So I'll just do it in the fastest way possible, and that is, if you remember, I'm using the method where I look at the whole equation and say what's the common denominator. It's 6. So I multiply everything through by 6. So I'll do this in my head. It'll be on the recording as well, but it'll look magical if you just look at the notes back. But if I multiply the first fraction by 6, the 3 and this will cancel into 6 twice. So I'll be left with 2 times 2x. If I multiply x on 2 by 6, 2 will go into 6 3 times. So I'll have 3 times x. And then I'll have 35 times 6, which is... Someone want to do it for me? 210. Sorry? 210. 210, thank you. Is that okay with everyone? Okay, so really quickly, I'm going to erase it after I've done it, but I had 2x on 3 and I multiplied that by 6. That's where I got 2 times 2x. Then I had then I had x on 2, which I multiplied by 6, and that gave me 3x. And then I had 35 times 6, which Otto told me was 210. Okay, just a calculator operation. As far as I'm concerned, calculators will be in for the exam, for the test. So 2 times 2x is 4x, so I've got 7x on the left, and I've got 210 on the right, and so x is equal to 30. Boom, boom, shake it and done. Anna, question?
No, I just got different things.
Okay.
X equals 36.
I'm not sure why. Look at the working out. Is there any step there you don't understand? Okay, if you've got individual, if you've got individual, okay, if you're not going to follow on with me, then there's no need to interject, I suppose. But if you're doing, if you've got any problems with that, just let me know when you get onto your own problems. Example 2, 1/2 of an integer is subtracted from 3/5. Sorry, I've squished that in. 3/5 of the next consecutive integer. Difference is 3. So this is a very common kind of worded question. The key word here is consecutive. Can someone please tell me what consecutive means? No one can tell me in the right way?
It's a set of numbers.
No one can tell me in the appropriate way. What's that?
It's a set of numbers that follow each other.
Yeah, that's pretty much it. So, yeah, one number following the other one. So, integer, by the way, you should be familiar with. What's an integer? No.
Like a number? whole number.
Whole number, good. Doesn't have to be positive. Chris, what didn't you do? What didn't you do? What didn't you do? That's why I didn't call on it. What's the deliberate ignorance? Okay, yeah, has any whole number. So 0, -7, 142, they're all integers. Pi is not an integer. Okay, difference is 3. So same idea. You'll see we go straight into that fraction notation. So 1/2 of an integer. So let that integer be x. So x on 2 is 1/2. Is subtracted from 3/5 of the next consecutive integer. Is subtracted from. Ouch, shouldn't have started. Is subtracted from. So I'm starting off with 3/5 of the next consecutive integer. Oh, that's even more tricky. Excuse me, back I go. Here we go. If x is one integer, x plus 1 is the next. So what do we actually have? We have 1/2 of an integer is subtracted from 3/5 of the next consecutive integer. I'll zoom out so you can see the problem along with the solution. So we're going to have 3 outside of x plus 1 over 5. That's 3/5 of the next number minus x on 2 is equal to 3. The difference means the result from subtraction. Okay, same deal now. I'm going to multiply through by the common denominator. In this case, it's 10. So if I multiply the first one by 10, 5 goes into 10 twice. So I'll end up with 6 outside of x plus 1. If I multiply the second part by 10, the 2 will go to 10 5 times. So I'll be left with 5x. And if I multiply 3 by 10, I get 30. Stop there for a moment, ask questions. Okay, now it's just a matter of expanding and collecting my terms and solving. So this should be bread and butter for you right now. 6x take 5x is 1x, so I've got x on the left-hand side, and 30 take 6 is 24. So the result is x equals 24. Any questions before I move on? Yep.
Would you expect a written answer after that saying that the starting number was 24 or not?
Actually, even more so than that, thank you for calling me on that, because the question is, I didn't write it down, but the question is, what are those two numbers? If I write x equals 24, I've just solved it, but I haven't answered the question. Therefore, the two numbers are 24, 25. So if this was a question out of 3, writing x equals 24 will get you 2. Writing 24 and 25 will get you 3. So really good pick up there. Okay, same with the first one, so I really should have finished it off. This is me just trying to rush. Example 3, remember the video's out there, and you'll be able to catch up on your notes if I'm going too fast for you. If the reciprocal of a number is added to 4 times the reciprocal of that number, the result is 5/9. Here's the key word here, reciprocal. Who can tell me what reciprocal means? You can do it by example if it's hard to explain.
You like flip it? Oh.
Violet.
It's the you flip it to make a division and then multiplication.
Right, want to give me an example?
Like
What's the reciprocal of 2/3?
3/2.
Okay, you flip it. What's the reciprocal, Jack? What's the reciprocal? Sorry to click on the spot, so it's okay if you can't get it. What's the reciprocal of 4?
1/4.
Perfect. Okay, so integers can be reciprocalized. They just become 1/, as can 1/overs. So the reciprocal of a third is 3. Okay, so the only thing you can't get a reciprocal of is 0, really. Okay, so let's have a look at it. Let x be the number. I'm just starting off with that. So solution. So let x be the number. If the reciprocal of a number, so it's 1 on x, is added to 4 times the reciprocal of that number, that's 4 on x. Does that kind of make sense? 4 lots of 1 on x. 4 times the reciprocal of that number. Just be careful. What would the reciprocal of 4 times the number look like? See how I changed those words over? Mathematics very much has a strong literacy element to it. 4 times the reciprocal is 4 on x, 4 times 1 on x. What's the reciprocal of 4 times the number?
Oh, it's 4x. No, 4x. 1/4.
Yeah. 4x under 1 or 1 over 4x. Good. Thanks, Otto. Although I shouldn't have called, called out, that's okay. 1 on x plus 4 on x is what we're asked for, though. We're told the result is 5/9. This is not too bad to do at all. Pretty easy, this one. Solution, so we've got 1 on x plus 4 on x is equal to 5/9. So now I'm going to add those together. So I get 5 on x is equal to 5 on 9. Therefore, x is equal to 9 by equating denominators. i.e. the number is 9. That's my conclusion. Okay, next one. Example 4 is a long one, so you probably won't have a chance to write it down. Ariana took 2 hours longer to drive 360 kilometres on the first day of a trip than she took to drive 270 kilometres on the second day. If her speed was the same on both days, what was the driving time each day? Okay, so we've got quite a few facts there. This is a rate problem, and there is definitely going to be one in the test. And you really only need to know that speed equals distance over time, and therefore distance equals Jack? Time times speed, or time is equal to Charlie? Not quite. Swap it in your head. Maddie? Distance over speed. So you'll be given one of those combinations in the test, and you'll be expected to be able to manipulate the speed equals distance over time equation and then substitute stuff in. But let's see how to do this one. This one's a bit more straightforward. Ariana took 2 hours longer to drive 360 kilometres on the first day of a trip. Okay, so let's say let's use a different variable just for the sake of it, because it's pretty common, this kind of one. Let t be the time taken on day 1. Okay. Then the speed is going to be equal to 300, what was it? 270 kilometres on, no, hang on. Took 2 hours longer to drive 360 kilometres on the first day of a trip than she took to drive 270 kilometres on the second day. Okay, so this gets a bit tricky. That's okay, we can do it. Speed is equal to 360 over x, right? Distance, 360 over time, which is x, on day 1.
Is it T or X?
Yep, t, sorry. Okay, on day 2, speed is equal to what?
270.
Nearly. 270 is the distance, but what is the time on day 2?
T.
Think about it for a moment. It's not t. Maddie.
T minus 2.
T minus 2. Well done. T minus 2. Can you see that? Does that make sense to everybody? So you've got to be careful. Although it says 2 hours longer to drive it, that means on the second day she took 2 hours shorter. So you've got to be careful of that. An alternative would have been to say, let t be the time on day 2, therefore t plus 2 is the time on day 1. So you could have done it that way as well. But anyway, it's the same speed each day. So therefore, we have 360 over t is equal to 270 over t minus 2. Now we're going to use that trick of cross multiplying, where we multiply the left-hand side by the right-hand side denominator and vice versa. So we get 360 outside of t minus 2 is equal to 270 multiplied by t. So I'll now expand that. Now I'm going to do a swapsies. I'm going to take 270t from both sides, and that'll leave me with 90t. And I'm going to add 720 to both sides, and that'll give me 720 on the right. And I reckon I can do that in my head because I know that 9 eighths are 700 and the 9 eighths are 72. I feel like this is giving me a really small answer though. So I think that's 8. Oh yeah, hours, that's right, it's not speed, it's hours. Okay, so t equals 8. i.e. she travelled 8 hours on day 1 and she travelled 6 hours on day 2. Done. That's the last example I want to go through. I'll leave that up there because there's a bit of writing to write up. I'm going to stop the video though. So you've got a worksheet in front of you. Do every odd problem, and we're going to stop in about 15 minutes where I want to show you one more application of algebraic fractions.